All right, so I am sharing my screen. We have already worked through questions 2 and 3 from homework 7. So question 4 is the last one, I believe. All right, so we've got some enclosure that we're calculating, a rectangular portion and a semicircular portion with dimensions as shown in the diagram above. We're going to fence it, right? So there's nothing here. It's just this outer portion. And as described below, we're going to be writing a program that determines the cost of fence for the enclosure. The cost per foot, cost C, is for the curved portion, which is more expensive than the straight portion, cost S. So we're starting for A is writing a function that will accept input arguments of area and radius, the two costs, and return an output argument, the total cost of the fence. So we need to come up with an equation to solve for L based on A and R. Right, so if I maybe try and do that to begin. So we know, I'll put this one here. I'm trying to calculate L if I know A. So equation for the area, well, the rectangular area is just L times 2R. And then we're going to add to that the semicircle here. Well, I know the area of a circle is pi r squared, so 0.5 times pi times r squared. All right, so we're going to be given an a, that's an input for our function. We're going to be given the r, so we know everything except for L. So we can rearrange that, I think, maybe subtract this term off to the other side. So I've got a minus that term equals this stuff. And then if we want to get rid of this, I'm just going to divide by 2r. So L should equal everything on the left-hand side divided by the 2r term. But of course, everything over here needed to be in parentheses for our order of operations. Okay, so again, I think this is I did this by hand first, so if you want to do that, it'll help you think through the problem. But I've got a minus pi r squared over 2, a minus pi r squared over 2, all divided by 2r. So looking good, there's my L. All right, and I think you can go away. So now we're ready to begin. So for this one, there's going to be kind of two parts. The first thing we're going to create is a new function. My output, it said, was the total cost. Maybe I'll just call that cost. My inputs, there were 4 of them. The first was the area. The second was the radius. I'll just call R. And then cost C, cost S. Cost C, cost S. And this is supposed to be called fence cost. Okay, so fence cost calculates total cost of fence using inputs of enclosed area and radius R. Straight portion of fence has cost per foot cost. Actually, we don't know if it's feet, cost per unit, cost per length, cost C, and cost of curved portion is cost and cost per length curved portion is cost C. That's straight. All right, so we're going to calculate the total cost of the fence using inputs of the enclosed area and radius r. Straight portion of the fence has a cost per length, cost s, s for straight, and cost per length of curved portion is cost c. All right, so I think we're ready to begin. First thing we need to do is come up with our L value. So length, just capital L, equals, that was the formula we had come up with previously. So length was, I probably can just copy and paste right from here. Area minus 1/2 of pi times r squared divided by 2r. All right, so now we have our length. So I guess now it's time to go back to the problem statement. All right, so we can come up with the total straight maybe. So total straight, that's our total length of our straight. For the straight portions, we've got an L, we've got 2r, and then up top we've got another L. So I've got 1L plus another L plus 2r. And then we've got the curved section. All right, so that's just right here. Well, that's half of a circle. And I know the perimeter of a circle is 2 pi r. So half of that would just be pi r. So pi times r. And then our cost equals total s times cost s plus total c times cost c. Convince yourself that that's right, but this is our cost per length of the straight portion, and this is our total length of the straight portion. So boom, multiply them. There's our cost for the straight part. Same thing over here for the curved part. And I believe that takes care of our function. So I'm going to go ahead and save that. This is our March 31. I should make a new folder. Question 4. We'll save that right in there, and then I'll make sure I'm working out of that folder as well. So I am March 31, question 4 is the folder I'm working out of. Okay, so I believe that's working. And then we have some values here to double check that it is. So our area is 3,000 square feet. Our FR radius is 20 feet with a cost C of 12 and a cost S of 9. We should be able to test our function. So fence cost is in there. Let's try it. So C equals fence cost. And we start with our area, 3,000. Our radius, 20, cost C, 12, cost S, 9. If I run that, I get 2181. And that looks like it. So despite my poor formatting, format shorts maybe, or, well, despite my poor formatting, we've still got a correct number, it looks like. Okay, so that's part A, all done. And I don't think we need to use that anymore. We're going to be using it later. But actually, the one thing I did want to say is we didn't generalize this very well to take in our function to take vectors. So maybe we should just make sure we are. So that's scalar, scalar times maybe a vector. Scalar times a vector is fine. Adding vectors is fine. And I think we would have been fine without them, but it will. Okie dokie. Way too many windows open right now. And that's my notes on my other screen. So I'll keep that one. All right, so it looks like our function's working. So let's move on to part B, which I think I need a new script for. All right, part B says write a script that uses a nested for loop and fprintf to print a table of our fence costs formatted as shown below for R values ranging from 10 to 40 in steps of 5, and area ranging from 2,500 to 3,500 in steps of 100, keeping the same costs as before. Call the function when scalar values are an area. So we're not using any vectorization here. We're just calling it repeatedly inside of for loops and then printing some stuff. So this one took me quite a bit of trial and error to get my spacing right. We'll probably have to do that as well, but we're trying not to use any arrays in this program. All right. My function, now that my function exists, I think I could just call it. So here's my, let's see, we're gonna need to create our cost C, which was 12. Cost, I guess, use a little pseudocode here. So initialize constant. We're going to need to do whatever. I think we're going to have a couple before we do our for loop to create this part. We're going to display title, table title. And we're going to calc and display values. And that's going to be using for loop. Okay, so our cost now straight was 9. I think that's it. That's really all the very early constants that we have, things that don't change. So we can start with our titles. Well, I've got it right there. That's the first title. There's no numbers or anything that I'm trying to show, but I do want a couple of spaces, so I'll use the fprintf and paste that on there. And then before I'm done, a couple of new lines. So I'm gonna make this big so you can see everything. So it's just that statement that was at the title there. The next thing I've got is that portion, but this one doesn't have any values either and no returns or anything. So I'll display that, and I'll work on the spacing here in a bit. And then we need to display this line, feet squared. So those are the titles of our chart. And then on this very next line is where we need to start our for loop to calculate all the inner values. So, okay, so for our our areas go from 2,500 by 100 to 3,500. All right, so then the first thing I'm going to want to do is every time my area changes, so the 2,500, I'm going to do all of my radius changes, and then the next time I need to display the area again and then display all my changes that are changed with the radius, which is my inner loop. So before I start my inner loop, I'm going to do an f print f to put the very first area on there. And if you look, there's a whole bunch of spaces. So I'm going to start with some spaces. I don't know how many, but then I want to put, this is just going to be an integer. So %i is how we say integer, and report our area. And I don't want to put a return the /n because on the same line is where I'm going to be putting my next stuff. So I'm just going to start my for radius, which goes from 10 by 5 to 40. Now I need to calculate the fence cost. And I don't want any of the decimals. You notice that on the table there's no, we're just going to be rounding down. So that's the floor function. Call our fence cost using, let's see, what did I, oops, I forgot my equal sign up here for area. For area, radius, cost C, cost S. So I'm going to calculate a cost based on the current value of A and R. Then I want to display it, and then I want to calculate the next one. So f print f to display it. And again, we ended our when we showed our area, the 2500, we ended, and then there's a whole bunch of spaces. So here I'm going to start with a whole bunch of spaces, and then my number with a $sign. So $, again, % I, because we know it's an integer, we rounded it down to the next lower integer for our cost. So we're displaying our cost as an integer. Again, formatting is all going to be taken care of at the end. So that's the end there. All right, so when we get to the end of our radius values, now we need to jump to the next line before we restart our new area, before we display our new area. So after this end, I'm going to f print f, just a new line. All right, so I put in the, I'm going to just talk my way through it just to make sure. I put in the titles up top, that's there, there, and there. Then I came in and I put some spaces, and then I reported my area. And then I defined R and used the area and the R values to calculate numbers. Once I got to the end of my R values, I do a return. I report each of those with some spaces. So spaces first value, spaces next value, spaces next value. Once I get to the end of the line, return. That's where I will jump back up, do the next area value, do the next set of values, rinse and repeat. So let's take a look at how this is looking. Maybe a CLC and a clear up top. Run it. This is homework 7, question 4, and we might do it all together, so I won't put an A, B, or C. I hit save. All of this is reporting out at my window. Actually, I should just minimize you because I want to compare these two. All right, so I mean, not bad. I think I forgot to close the parentheses on my area. Sure did. So my area is closed. I think I want my feet squared to scoot over so it goes out past the area, and then I kind of want those to line up. So I think I got the line up on my area and my first A. So I just need to scoot my R's over. which means a few more spaces at the beginning. All right, I think that looks maybe a little bit further. Yeah, and in fact, one more space there might line up my 10 as well, so. There we go, so we got the 10 and my first value. Looks like maybe I shouldn't have floored, I should have rounded instead, but oh well. So I think I need a few more spaces on to get my 15 lined up. So there's where my 15 starts. 15's now, oh, I nailed it, is now lined up. 20 needs a few more spaces. In fact, maybe I should just, that set of spacing seems right. So I'm gonna paste that over all of these other ones. All right, hit run, and let's just see. Okay, my 10s are lined up. 15s, 20s, 25s, 30s, 35s, and 40s are all lined up. I did notice that maybe instead of using floor, I want to just round. I think that's the function, but double check. Rounds to the nearest integer works for me. And now I think my values match. So a little bit of weird formatting, but I think we got there. And I don't know, maybe I'll count how many spaces I have. 1, 2, 3, 4, 5, 6, 7, 8. 8 total spaces there. It might help you figure it out. Okay. So we just calculated or did part A. And what does part B ask for? Oh, this was part B. Part A was the function. So this is homework 7, question 4B. What is he asking? And I don't think there was a single array in this whole thing, just like we were asked to do. Part C asks us to use a vectorized approach instead, making use of the mesh grid function to calculate all the same fence cost values above without using any loops. This time, still using the fence cost function to do the calc. And this time we're going to display it as instead of in a table, but as a 3D plot. Okay, that doesn't sound too bad. I think we've got our area vector here, but I'm gonna call that little a because typically when you use the mesh grid, you use capital for the mesh. So there's A and R, as we were asked to do those. And then the mesh grid part, A and R, come from the mesh grid, which is going to mesh A and R. So if I run this section, too many windows open. If I run that section, now I should have a capital A, which is 7 by 11. So I assume there's 11 here and 7 here. 7 by 11, same thing with R, 7 by 11. And now if we hopefully did our cost function right to take vectors or matrices, we should now be able to just return a bit so we can have a little space. Now we should just be able to create our fence costs. So it's not the same variable name as our function fence cost. Our fence costs are calling our fence cost function using our matrix A, matrix R. I don't have a cost C or cost S described yet. C, cost S. And I'm going to run it right here just to see if we error out. Nope, looks like we now have a fence costs 7x11 double. So it looks like it's working out for me. Of course, I want to now show that. So I like surf. So that takes my two inputs, A and R, and then my Z will be fence costs. And those all have the same, if I look in my workspace here, they all have the same 7x11. So they should match up nicely. But I believe it asks us to properly labeled. So our x-axis, well, that was the first thing we did, so that's area. And it's probably, I think, in feet squared. Oh, and that's not x-axis, that's x-label. Y-label is the radius, and that's just in feet. And our Z-label is the fence cost in dollar bills. And then maybe even a title, why not? Fence cost as a function of area and radius. All right, I'm gonna hit run. And there we go. Our area does go from 2,500 to 3,500, looks good. Our radius does go from 10 to 40. And our cost, just to make sure it makes sense, it looks like as we increase the area, the cost goes up in general, which I believe makes sense because a bigger area typically is going to use more fencing, so our cost should go up. It looks like in our radius dimension, if you start with a really small side, your cost goes way high. That probably is because it's a long, skinny fence. Same thing, there's some kind of a minimum here, and if you let the other side get really big, maybe you're long and skinny in the other direction. So it looks like we have some kind of minimum in the 20 to 25 range, but it looks, I don't know, reasonable to me. So that's just a little bit of validation to see if our answers look right, and it does. The bigger we get, the cost of the fencing seems to go up. And then if we have a weird shape, typically something square is kind of the most efficient. So you don't want a big weirdly shaped rectangle. So we have some kind of a minimum in here. So that all looks good. I think that takes care of part B, or C, I'm sorry. So then part D asks us to write a script that prompts the user for the enclosure area, determines and outputs the minimum total fenced costs along with the dimensions R and L. The fencing costs, use the fencing cost per foot from above, test it using 3000. And there's a hint using fmin bound. Okay. So now this is homework 7, question 4, part D. Here, I'll just put my screen on C in case you need to pause it and fix anything or do anything, but there you go. All right, part D. I believe we need to specify our area using the input. What is the area of your enclosure? But you all know how I feel about using the input function, so I'm just going to say area equals 3000, so I never have to go to my command window and actually answer the question, but it's there, it exists. We can swap comment this line out and uncomment that line out if I want to do it in that direction. Of course, my cost C is still 12. My cost S is still 9. All right, so our hint says use on a fmin bound on a function handle that calls our fence cost function, but only as a function of R. So because we have A defined above as a number, it's already a scalar. So I think we can say something like our cost handle is at R is the variable we're going to let be in it. And all we do is call fence cost using area, which is just a number. It's not a variable now. It's just a number defined above. R is the variable, cost C, and cost S. Right, so there's our function handle. To use the fmin bound, we need guesses, a left and a right guessed. So I think before I can do that, I'm going to do some kind of an f-plot. We're going to plot our cost handle. F-plot needs a function and then some x interval. For now, I'm just going to do the cost handle just to see what it looks like. So if I run my section, well, that didn't get me anything. Did I misspell something? Oh, that's why. We're having some kind of a crazy error, but I think I see why. When I called my function, it should have just been fence cost. That was my function name, not costs. Okay, there we go. All right, now it doesn't make sense to have negative values, right? And I think we need, this seems like it's trying to do something. So I might, to keep my scale small right now, it's going up way up to 25,000, 2,000, yeah, 25,000. So I know my min's going to be out here somewhere. So I might start my value, I don't know, like 1, right? So again, if we look at the help menu here, we can give the function and some x interval that we care about. It looked like by default they went from -5 to 5. The negatives don't make sense to us, and we know we're looking for a min, so maybe I'm just going to go from like 1 to something. 1 to 10. We were doing radiuses up to 40 last time, so maybe 1 to 100, just to make sure we kind of see the area. All right, so run the section. There we go. All right, there we go. So now it looks like our min is somewhere, I don't know, definitely between 10 and 30. Right, so maybe I'll change my window just a little bit, 10 to 40. That was kind of the bounds we were using earlier. Now my plot, I can clearly see a minimum there, definitely between 20 and 30. So now I think I'm ready to use my fmin bound. So our minimum cost, the radius that corresponds with it, is fmin bound. Cost handle is the function we're trying to minimize, and we're going to be going between 20 and 30 are the left and right bounds that we are going to go from. So if I hit run and take a look over here, okay, my min cost radius looks like it's right in the middle, 25.5-ish between the two. So that tells me what radius has the smallest cost. But to find out what the actual smallest cost was, now I need to report the min cost. Fmin, nope, I just need to call my cost handle using the single input min cost radius, that radius that had the min cost. Both of those can get suppressed. What are we asked to actually report? So we want to give the corresponding radius and R and L values. We already have R. Min cost R is the smallest R, but we don't know what the L value is yet. And then report the min cost. All right, so I think if we are going to need to go into our function and let our L be an output as well. Or maybe just grab the equation for L from area. That might be better, which I think we have that in our fins cost function. So if I open up my fins cost function, there's the equation for L. So now I'm working on reporting my values. So the area, just to make it match my current syntax, area, we're using this as our R value. So now we know our minimum, the R that the minimum cost occurs at, that defines the L that the minimum cost occurs at, and we can do some kind of an F print F, your min, so the minimum cost of your, here I'm going to put the area, percent I foot squared enclosure, give it a new line there, occurs when your radius is another integer. Actually, I'm not entirely sure these are going to be integers, so maybe I'll do like 0.2f feet, and length is okay. So let's just, I'm going to make this big so we can read the whole thing. We're displaying the minimum cost of your, in case they gave me a decimal, I guess I should 0.2f foot squared enclosure occurs when your radius is that. Maybe another new line right there. And the length is that in feet, comma, area, R, min cost, R, L. Who knows if that worked? We'll see. I lost the capitalization somewhere or something. Yep, right there. And then I never did report the min cost. F print F, minimum cost is .2 F new line. I don't know if I had a new line at the end of my last one. No, I didn't. The minimum cost is and that's min cost variable. All right, run section. Let's see here. Well, we've got a whole bunch of words showing up, so that's good. The minimum cost of your 3,000 foot squared enclosure occurs, I need to take that space out, when your radius is 25.49 feet and the length is 38.83 feet. The minimum cost is $2,118.65. Looks good, other than that space before the occurs. Go away. The minimum cost of your 3,000 foot squared enclosure occurs when your radius is 25.49 feet and length is 38.83 feet. The minimum cost is $2,118.65. All right, looks good to me. Let's just make sure we answered all the questions. Yep, that was the end. And we did, in fact, answer all the things they're asking for. So that is the end of homework 7. I hope you will use this and it'll help you prepare a little bit for your test on Tuesday. See you then.